Okay, so let's consider the following example. Let's consider map T, transformation T, which is mapping from R3 into R3, and it's defined by this matrix A above, which has column 1, which is 1, minus 4, 5. Column 2 is minus 3, 1, 3, and then the last column is 2, 0, minus 9. So we're going to define this transformation T as what we get when we multiply some arbitrary vector in R3 by the matrix A. So the first question is asking us to find where the image of what these standard column vectors are getting mapped to. So we'll let E1 denote the column vector that contains all zeros except for a 1 in the first position. And then E2 is the column vector of all zeros except for a 1 in the second position. And then E3 has a 1 in the third position and zeros everywhere else. And so if we want to see where this first vector E1 gets mapped to, well, this is saying we're going to take E1, which is 1, 0, 0, and we're going to multiply A times that vector. So A, again, is the same matrix that we had up top. So based on how we define matrix vector multiplication, what we're going to get is the number 1 times the first column. So that would pull off the first column of this matrix, which is the 1, minus 4, 5, plus 0 times this column, plus 0 times the third column. So all that's going to be left over is going to be the 1 times the first column. So the image of E1 is the first column of matrix A, which is 1, minus 4, 5. And for the next one, if we want to see what is the image of E2, again, we take matrix A now times the vector E2, 0, 1, 0. So we're going to take 0 times the first column, that's going to give me the 0 vector, plus 1 times column 2, plus 0 times the third column, which again would give me the 0 vector. So I have the only thing that's going to be left after doing this multiplication is going to be that second column, which is the 3, 1, minus 3. And if you're thinking, well, what's going to happen to T of E3, and hopefully you're picking up on the pattern that this would just pull off the third column of matrix A. Next, let's consider the following question. We have some vector B in the codomain, right, which is R3. So we'll let B be the vector 1, 1, 1. And we'd like to know, is this vector B in the range of this transformation T? So in other words, what we're like to know is there some X in R3 that gets mapped to B, which we defined as the vector of 1, 1, 1. And so this has the following matrix equation that we see over here, where we've got the matrix first column 1, minus 4, 5, second column minus 3, 1, 3, third column 2, 0, 9, times the vector x1, x2, x3 equals the vector B, which is 1, 1, 1. And so if we want to solve this matrix equation, we can set up the corresponding augmented matrix. So I just pull off column 1 of vector A, column 2 of vector A, column 3 of vector A, and now we add a fourth column, which is 1, 1, 1. We can do some elementary row operations on this vector. I would suggest practicing Python, and in particular using the SymPy library that we did in our Python lab to find the reduced row echelon form of this matrix. And I'm writing it out below because this one does not work out all that nicely, and that's where the technology will be quite nice. But the reduced row echelon form of this matrix I've written below. These decimals, keep in mind, are not repeating. They just go on for forever. But we can see that this matrix, the first column is 1, 0, 0. So column 1 has a pivot. The second column is 0, 1, 0. Column 2 has a pivot. And the third column in this reduced row echelon form is 0, 0, 1. So since every variable is a basic variable, we can see that this does have a solution, and in fact, it's a unique solution. But because we can find the solution, this tells us that the vector b, which is 1, 1, 1, is indeed in the range of this function, and its pre-image is given by this vector over here, which is minus 0.4923-ish, followed by minus, then we would set x2 equal to minus 0.9623, and so on. X3 is going to be approximately minus 0.7077. So yes, this has a pre-image that we found by putting the corresponding augmented matrix into reduced row echelon form.